This is video number 14 from digital-university.org concerning our series on electrical circuit analysis techniques. In this video, we're going to apply the method of the mesh current analysis again using the format approach. And this is the circuit that we're going to apply it to. And here it's, again, a direct current circuit. Our first 30 or so videos we're going to be dealing almost exclusively with direct currents. And to use the format approach, there cannot be any current sources in the circuit. If you do have a current source, sometimes you can convert it numerically to a voltage source with a source conversion technique, and we'll go over that in some of the future videos. Okay, for this one, let's take a look now at how we can use the mesh analysis format approach to determine currents I1, I2, and I3. So we start with the first loop, and here we see I2 flows through these two resistors, each of value 1. 1 plus 1 is 2, so we have 2 times I1. Then we subtract the other currents that might flow through these resistors. So here we'd have minus I2 times 1 and minus 1 times I sub 3. And that will be equal to what voltage source is in this loop. And here the current, we're drawing it as going through the battery from a lower potential to a higher potential. So that's a plus 13, that's a plus voltage then, so we put it on this side as plus 13 volts. So that right there is our first mesh current equation. Now we go to this loop, and current I2 flows through this resistor, this resistor, this resistor. So we have 3 I2, and then we're going to have minus I1, and then I3 goes through this resistor, so I have minus 1 times I3, and no voltage source in that loop, so it's set equal to 0, and this is our second mesh current equation. Now let's go down to the third loop. Here we have I3 flowing through 1, adds up to 2, plus 2 adds up to 4, so we have 4 I3, and then we subtract. Through this resistor we have I1 in the opposite direction, so we have minus 1 times I1, and here we have I2 flowing through the opposite direction in that resistor, so you have minus 1 times I2. No voltage source here, so that equals 0. And there we have it. Those are our three mesh current equations. Now, let's do this. Let's take the coefficients of, say, I1. See, it's 2, negative 1, negative 1, make a column with them. So you have 2, negative 1, negative 1. And that is our coefficients of I1. Now let's do the same for I2. Here we have negative 1 plus 3, negative 1. So we have negative 1, 3, negative 1. And let's do the same for I3. Here we have negative 1, negative 1, 4. So what we did here then, we used the coefficients of I1, I2, I3, wrote them in columns, and now we have a 3 by 3 determinant. Now, to solve for I1, I2, and I3, our three unknown currents, we have three unknowns, here, 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 and three separate equations. To solve for them, first step is determine what is the numerical value of this determinant. So let's take care of that first. Then that'll put us in a position where we can quite readily determine what I1, I2, and I3 are. Okay, so the numerical value of this, we're going to expand it out using minors. So we'll have 2. And then 2 will be multiplied by this submatrix. Cover up this row, cover up this column, and we have 3, -1, -1, 4. Okay, then it's minus this number, which has a minus sign before it, so that's going to make this +1 times this subdeterminant. Cover up the row that this number appears in, and cover up the column that it appears in. And now we have this subdeterminant, -1, -1, -1, 4. Okay, and then here this is a minus sign, so we have -1 times this subdeterminant. Cover up the column, cover up the row, and we have -1, -1, 3, -1. Okay, so what we did was we took this determinant and we expanded it out using minors. Now, let's see, what's the value of this subdeterminant? Here we have 12 minus 1, that would be 11. Here we have -4 minus +1, that will be -5. And here we have 1 minus -3, that would be 1 plus 3, so this is 4. So let's see what we have. We have 2 times 11, that's 22. 1 times -5, -5 minus 1 times 4. 22 minus 9 is 13. So the value of this determinant is 13. Okay, now we're in a position where we can quite readily determine the value of I1, I2, and I3. And again, it's the same deal as what you saw us do in the previous videos. To determine I1, we replace this column with this column, 1300. Leave these two columns alone. So I1 will be equal to this determinant, 1300, -1, 3, -1. And here, -1, -1, 4. I1 is equal to this, the value of this determinant divided by 13. And to determine I2, it's the same setup, except this column gets replaced by this column to form a different determinant that is also divided by 13. And to determine I3, this column gets replaced. We put this in its place here. We have a different determinant, and that determinant as well is divided by 13. And that will enable us to find the values of current 1, current 2, and current 3. So let's go ahead. Determine the value of what this is, this determinant here. Expanding across by minors again, we have 13 times, and again, cover up that column, cover up that row, and hopefully you can see it all right. There is a 3, -1, and a -1, 4. Okay, then it's minus the next number, which has a minus sign by it, so that becomes a plus. And again, cover up the column, cover up the row that it appears in. Like this. Try to put into better focus. Here we have 0, 0, -1, 4. Okay, the next number, -1. -1 times this subdeterminant. Cover up the column, cover up the row, and we have 0, 0, 3, -1. Okay, now clearly the value of these two subdeterminants is 0, because we have 0 minus 0, and same thing here. So I1, now we determine the value of this subdeterminant. Here we have 12 minus 1, so that's 11. So we have I1 is equal to 13 times 11 divided by 13. So I1 is equal to plus 11 amps. So let's just go up to here. I1 equals plus 11 amps. Okay, that was pretty straightforward. Let's see if we can quickly determine I2 and I3. Now for I2, now we replace this column with this column of numbers. So here for I2, we have 2, -1, -1, 13, 0, 0, and then for I3 we have -1, -1, 4. And that is divided by 13. So let's just see if we can quickly go through this. Here we have expanding by minors. This will be equal to, and sorry if this gets tedious, but for many of these techniques, they involve solving simultaneous equations, which means we have to work with determinants, and be careful going through them. It's easy to make a silly mistake. So let's go on and see if we can finish this off. Here we have this be equal to 2, and now times this subdeterminant, which has 0, 0, negative 1, 4, and clearly that's going to have a value of 0 because we're going to have 4 times 0 is 0, minus 1 times 0 is 0. So this is just 2 times 0. And then this is 13. And remember, it's minus that number, so we have minus 13 times this submatrix. Cover up the row and cover up the column. We have negative 1, negative 1, negative 1, 4. Hopefully you can see that all right. So we have negative 1, negative 1, 4, and then we have minus 1 times this submatrix. Like this, and clearly this one is going to be 0, because now we have 0 times negative 1 minus negative 1 times 0. So this is just 0. So we have now that I2 is equal to minus 13 times, here we have negative 4 minus 1. And that would be negative 4 plus negative 1, so that would be negative 5. Minus 13 times minus 5 divided by 13, and that equals plus 5 amps. So there is I2. Now we have to go ahead and determine what is I3. And I don't think we're going to have time in this video to do that. Come back and join us in the next video. Very quickly, we'll determine what I3 is, and then afterwards, we'll determine what the current is through each one of these resistors in the circuit. So come back, join us for that video, and we'll finish this off.